it's not.
Okay. Review using the distributive property, and we'll see if we get into the number system today as well, okay? We'll see if we get into the number system today as well. I'm not convinced we will. That's okay. Okay, reflex. Hey, so distributive property. Okay, you guys have learned this before, correct?
No, never.
Nope, never. Okay, we're hopeless. Okay, I know. Hi, just kidding. I'm Mr. Carlson. Nice to
Oh
meet you. Ooh. Okay.
no.
So distributive. Distributing or multiplying a value equally to two or more other values contained in parentheses. Okay. So here's an example of this. If you have A times B plus C, A times B plus C. Yes. Okay. That'd be the same thing as A times B plus A times C, right?
No.
Okay. We can multiply both of those. We distribute it, so to speak. Okay. How do we show that math often? How do we show the math often when we do distributive property? What do we do? Show me with your hands. What do we do?
What?
Okay. What would I do with this A to the B? Do you normally draw a little arc there?
Yeah.
You guys done that? Say we're going to distribute the A to the B, get A times B. Take A times C, distribute that, and get AC.
Oh, we did that a lot last year.
Yeah. Okay. Common thing. Okay. I still did it even when I was taking my Calc 3 course and passed that. Okay.
What the heck is calculus?
Right. Okay.
What the heck is it?
So, for example here, if we had like 3 times 2 plus 5, 3 times 2 plus 5. Okay. We're saying you can take and distribute that 3. We're saying you can distribute that 3. You don't just multiply the 3 times the 2, or just the 3 times the 5. You would distribute that. So what is 3 times 2?
That is
6. What's 3 times 5?
Or no, 15.
And we still keep that plus sign in between them, okay? Now, excuse me, what is 6 plus 15? 21.
21.
Okay, so we still end up getting 21, okay? If we went through the other way, guys, okay, and we did 3 times 2 plus 5, we went through a normal order of operations like we did in section 1.2, we would do the addition first there, right, inside the parentheses. What is 2 plus 5? 7, so we'd have 3 times 7. Hey, what is 3 times 7? 21. Hey, is it the same thing?
Yes.
That's why the distributive property works. It's because it ends up being the same thing. Now you might be wondering, Mr. Kossel, why do we use a distributive property? I feel like it would have been easier just to do 5 plus 2 first, okay? Maybe you're thinking that. Well, on some problems, it's going to be way easier to do the distributive property than that. And we'll see that in a minute here, okay? Questions on that? Okay, so using the order of operations, we're going to simplify this. 10 times 3 plus 5, okay? So we're going to simplify that using our order of operations. Order of operation tells us to do what first? Parentheses! The please and the please excuse my dear Aunt Sally, okay? So inside the parentheses, we're told to do what math? Add. 3 plus 5. What is 3 plus 5? 8, okay? Now what would we do according to the order of operations? Multiply. What is 10 times 8? 80, right?
Oh, I think.
We like multiplying by 10, or powers of 10 like 10, 100, 1,000, 10,000, 100,000, so on and so forth, because you just add zeros. Okay, we just took the 8 and added 1 0 to it. Okay, now let's practice doing that using our distributive property as well. Okay, so 10 times 3 plus 5. Okay, according to our distributive property, yes, Dylan. Okay, what would you do?
I did that. I did that. 10 times 3, which is 30, and then 10 times 5, which is 50. Then I add them.
Okay, so hold up 1 second. Okay, so 10 times 3, which is 30. Then we do 10 times 5, which is 50. We distribute. Okay, and then
I added those together, got 80.
and you add them together, and you still get 80, right? We get the same thing either way. Okay, we get the same thing either way. We get 80. Correct?
Correct.
Okay, Gucci Gang. Let's look right below this, some of these examples, okay? It says, rewrite each expression, aka we're simplifying the expression, using the distributive property, and then we're going to evaluate. So we're going to rewrite it using the distributive property, so we're going to distribute, then we're going to evaluate. We're going to distribute, then we're going to evaluate, okay? So in this first one, actually I'm going to have you guys go ahead and do the first one on your own. Go ahead and do the first one on your own, okay? When you are done, I want you to raise your hand. When you're done or you have questions, raise your hand, okay? I want you guys to use the distributed property, okay? Not order of operations, I want you guys to use the distributed property. Very good. Very good, thank you. That's still the right answer. We're back to the different method right now. And once you finish that first one, go ahead and go on to the second one there.
Oh, did I go on the second one?
Yeah, a lot of you have already, okay? Oh, okay. Oh, okay.
Whoa. Whoa.
So, over here, if we do this distributed property, right? 9 times 5 is 45. Okay, if you need the reminder on the hands, okay? Get this. Boop, boop, boop. Hold on the fifth finger. 1, 2, 3, 4, 4. 1, 2, 3, 4, 5. 45. Okay? 9 times 1, anything has 1 of itself, so it's 9. 45 plus 9 is 54. Okay? Could we get the same answer by doing 9 times 6? Because 5 plus 1 is 6. Yeah, we could, okay? We're trying to distribute property, okay? Here, 3 times 11 is 33. 3 times 8 is 24. What sign is going between these two? Subtraction. We have to be careful that the sign stays the same there, okay? Sign stays the same. So what is 33 minus 24? 9. 9. Questions on that?
Why do you say
9.
like German? 9.
I live and breathe memes. Okay. It's German for no. It's spelled 9. 9. But it's German. It's German, so it's pronounced 9. And it just means no. But anyway, hey, so let's practice this algebraic expression, okay? So we can apply the distributive property to this algebraic expression. So when we simplify 6 times 2x plus 1, when we simplify 6 times 2x plus 1, we could write it out 6 times. We could do 2x plus 1 plus 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 2x plus 1.
Yeah, I'm just write this.
Man, this is a bear.
Do we have to?
I don't know. What can we do instead that would be faster than this?
The 6 power.
Oh, we can do the distributive property, okay? So let's write it down here. Okay, let's write this down here. Okay? So what if we use a distributive property? We could say, what's 6 times 2x? 12x. What's 6 times 1? 6, and we have a plus. So we end up getting 12x plus 6. If we went through here and we added all of our like terms, 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10, plus 2 is 12. 12x. And we add up all of our ones. 1, 2, 3, 4, 5, 6. I'm getting mixed up with the pluses. 12x plus 6. We get the same answer either way, right? But is this one a lot easier now? Okay, so this is when the distributive property really comes in handy, is when we have algebraic expressions. And hey, guess what? This is called algebra 1, okay? So we're going to be dealing with algebraic expressions a decent amount, okay? So this distributive property is going to be quite the friend of ours this year in class, okay? Does that make sense?
No.
Okay, moving on.
How can it be our friend if it's math? Math is not
Math is amazing.
But math
You
is
ever
not
seen School of Rock?
Yes.
Math
Yeah.
is a beautiful thing.
It's a good night.
Okay.
You should show it to us,
You
like,
need to be cultured. Okay, probably not.
like cultured swine.
Yes. Okay.
What does that mean?
So I want you guys to. Okay. I want you guys to do number 1 and 2. I want you to do number 1 and 2. Just 1 and 2 for now.
It's 12 times 0.
It is. Last time I checked. Yes. Okay. Hey, when you're done, I want you to compare with somebody next to you. When you're done with both of them, I want you to compare with somebody next to you.
Oh, we totally missed.
Let's go even do the whip.
That is.
Hey, yours like.
So you're not gonna go me?
No. I'll be back there in 1 second. I gotta blow my nose.
One mile says in class I know how to Quit.
Would that be that? Okay.
Okay.
Is that right?
Remember, when you're done, compare with somebody next to you. When you're done, compare with somebody next to you. Okay. Okay. When you're done, compare with somebody next to you. I want everyone to compare. I want everyone to compare.
Wow, man.
Shirley, did you compare?
Oh, my
Presley, did you compare? Presley, compare with Shirley. You're
Wanna
done. You're done.
compare?
Sorry. You're done. Don't mean to rush.
I didn't have any.
Wait, is that a Z or is that a C?
That's a C. Not a two.
Oh,
I did it wrong. It's funny. I didn't do it right. Oh, yeah, yeah.
Yeah, I forgot.
Oh.
So let's come up here, let's look at this here, okay? So 12 times y plus 3, we do 12 times y, which is
12Y.
12y. 12 times 3, which is 36, and we add them together because we have the plus sign originally, okay? Question on that first one. Second one, what's different about this one?
It has three numbers, 3 things.
It has 3 things, and what else?
It has a negative.
It has a negative. So we take a negative 3 times negative x, and we get what? Positive 3x. Okay? Keep in mind, negative times a negative. Now, since we already multiplied negative, is it still a negative 3 as we multiply negative y? Okay? So negative 3 times negative y ends up being what?
Positive 3Y.
Positive 3y. Okay? I heard some people getting confused with this. This is a z, not a 2. This is a z, not a 2. Okay? So it's negative 3 times positive z.
Negative 3Z.
Negative 3z.
Ooh, I got it right.
Okay.
I have it. I was thinking special deals.
Okay. We're gonna skip number 3. Flip your page. We're gonna skip number 3. I want you guys to do number 4 on your own. Okay. I want you guys to do number 4 on your own. distribute, you might want to simplify more if you can.
You want to see this problem how we already done last year? If we did one
What do you mean how you did last year?
Oh.
Let's talk about this one up here. Let's talk about this one up here, okay? So, you have to distribute a couple times here, right?
Yes,
Okay.
sir.
So 6 times x is 6x, and 6 times negative 2y is
Negative 12.
negative 12y, okay? Then we have this plus sign here, and we have 4 times negative 3x, which is
Negative 12.
negative 12x. Okay, then we have 4 times y, which is
4y.
4y. Hey, are we fully done though?
No.
No, we can still do more. What do we call this next step?
Combining like
like
terms.
Combine like terms. What is a like term? Okay, we're going to talk about that definition a little more closely here. But somebody give me an example of 2 things we can combine here. Presley. Very good. 6x and negative 12x. And we add those together, and what do we end up getting? Negative 6x. Very good. Okay. And then what else can we combine here? Danny?
Well, I was gonna say, I did it backwards.
You
Like,
put the y's first.
yeah.
Okay, that'd be okay. We'll talk about a few chapters from now what we typically do with that, but it's okay.
Okay.
So what else can we combine though?
Wait, what did we just combine?
The x's.
Oh, negative 12y.
Yeah.
and 4y.
Yep, and what do we end up getting, Danny?
Negative xy.
Negative 8y.
Oh yeah, that's what I
Okay.
read.
So we end up getting that as our answer, okay? Now Danny said, hey, Mr. Krause, I have negative 8y minus 6x, is that okay? Yeah, for now it's perfectly fine. We'll talk about later how we order that, but for now it's perfectly fine, okay? Questions on that at all? Okay, hopefully that's kind of ringing a bell now that we did that. Let's go right below this, and it says combining like terms. Hey, it's almost like this was a perfect transition into that. What? No way, okay? So a term is a number, variable, or a product or quotient of numbers and variables. Okay, it's a number, variable, or a product or quotient of a number and variable. Okay, so an example of a number, 5. What's an example of a variable? X. An example of a product, okay, of numbers and variables, maybe 3x. Okay, that was one term. Okay, just like we had 6x and negative 12x. Those were different terms. Okay, or a quotient. Okay, so you could have like 3x over 7. Okay, you could also have like maybe like 4x squared. Okay, that could be a term as well. So we have all these different terms. Okay. So there we have the number, a variable, a product of a number and a variable, quotient of a number and a variable, and another product of number and variable. Okay, so let's do some different examples of terms. Okay, now like terms contain the same variables. Like terms contain the same variables. So it's like we didn't mix up our x and our y's on the last problem, did we? No, we didn't. Okay, they contain the same variables with corresponding variables having the same powers. With corresponding variables having the same powers. So for example, you would not combine 3x and 4x squared because they have different powers of x. Okay, when it's squared, what is the first power? Okay. Now equivalent expressions. If we're saying equivalent, what's it mean to be equivalent? The same, right? Like equal, okay? So they denote mean the same value. They denote or mean the same value. If two expressions are equivalent, that means they equal the same thing, they're the same value. If we get something in simplest form, I know we kind of talked about simplifying a lot. That means there are no like terms or parentheses left in the expression. Okay, so if it's in simplest form, there are no like terms or parentheses left in the expression. Okay, that means we combine everything we possibly could.
I don't think I've ever wrote that word before.
Parentheses?
Yeah.
It's kind of weird to write. I had to double check. Make sure I spell this right, Mr. Crossell, okay? Coefficient. Coefficient is the numerical factor. Okay, it's a number. The numerical factor, and it's the number in front of variables. So it's the numerical factor, it's the number in front of variables. So for like up here in our examples, what's an example of a coefficient up here? What's the number in front of the variable? 3. The 3 is the coefficient. 3 is the coefficient of 3x. Here, what's the coefficient?
4.
Just 4. Okay, 4 is the coefficient. It's the number there, okay? Questions on that? Okay? Okay. Let's work on, let's go right below this. Okay, does anyone still need this? Gucci gang. Okay? Simplify each expression. If not possible, we're gonna write simplified, okay? So on this first one, actually on these, I want you to do these three, okay, we'll just do it again. Made up my mind. 17a plus 21a, are these like terms? Yeah, do they have the same variable? Yep. Are they to the same power? Yeah, they're both to the first power, so we can combine them. So we add the coefficients here. We combine the coefficients with 17 plus 21. 38a. And we leave it as a. We do not change it to a squared. The exponent stays the same. That's why we have to make sure they have the same exponent, because that stays the same. On the second one, of these three terms, which two are like? Annie?
12b, 6b.
Yep.
Yeah, and then 8b.
Okay, and 8b the second, right? Why is 6b not like these two?
E?
It's not squared, right? The exponent right up here, okay? This is to the power of 1, where these are to the power of 2, okay? So, we take 12 minus 8. What is 12 minus 8? 12 minus 8. 4. And then what's the variable behind it?
Squared.
B squared. 4b squared, okay? We still have the b squared there. Whenever we combine like terms, we leave that b squared there. And what else do we still have that we didn't do? Heard it? Plus 6b, very good. Okay? On number 3, do we see anything that we can combine there? No, they all have different exponents. And this one doesn't even have a variable, okay? So we say simplified, because it's already simplified. Questions on that? Okay. On letter D there, right below that, that's what we basically did in the first section. Just adding in, combining, okay? We're actually going to skip that for now. We're going to skip that for now. Don't cross it out yet. We're going to skip that for now, okay? I know, what? We can't cross it out, Mr. Costle, okay? I know, being all mean and stuff. Let's work on, I'm going to pass out a worksheet here. I know, 2 worksheets in one, man, worst, okay? We're going to pass, hey, so I originally, if you had looked up on the board, I know it's a little hard to read in that color, but I can change that to a different color.
It's purple.
But, I don't have purple right now. But anyway, if we look over there, I originally have that we're going to be reviewing on Thursday this week for this chapter, and then testing next Tuesday, but I'm actually changing that. So on Thursday we're going to do section 1.6, then maybe start some review, but then also next Tuesday we're going to continue reviewing, and then we'll test the following Thursday, okay? So then we test a week from Thursday, that's still 9 days from now, okay? 9 days from now, okay? So hey, make sure to write your name on this, okay? You might be able to get a couple problems started. We just have a few minutes left here, okay? So hopefully you guys were able to finish up that first worksheet and get close on that one. That way you only guys have this one. It shouldn't be too terrible on us since it's math we know. Okay? When's it gonna be due, guys?
Next class.
Next class, right? Okay. And me and Slade back with Mr. Coughlin is gonna have them do that next class.
Now can I ask
This
a
whole
question?
entire paper.
Yes. But there's no back.
This
Yes.
is not a math, well, it sort of is.
Wait, simplifying or?
Read it. When you were
So we don't have to
younger,
solve
when
it?
you were younger,